The Edge Protection Federation is the youngest of these trade organisations we're hearing about today. So I need to define edge protection very quickly, and one can quite simply say that it is protection against falls at any leading edge. And if I more specifically say that generally will exclude scaffolding, then you'll begin to imagine the sort of structures that we're talking about, where there is no effective protection unless it's provided by a particular method or system. Because, as I say, the scaffolding, by this definition, will not be there. And you can see here the types of structures that we're talking about, which are primarily within the construction industry, but not exclusively so. And it includes, you can see, things like flat roofs as well. So I ought to go further and just mention the EPF, because the Edge Protection Federation may be an organisation you're not familiar with. So very briefly, you can see that the sort of services that we intend to provide, and it is very much a forum for looking at edge protection issues within the industry. By its nature as a new organisation and a new industry, it's one that is changing, and there are lots of questions that are arising within our client marketplace as well. And there are many more issues beginning to arise as a result of some of the equipment and some of the building techniques that are being followed. The membership is deliberately quite tight, but it's quite focused as well. These are people that are specialists in the main in the field of edge protection, but also include people that have an enormous amount of experience of the scaffolding and false work and formwork industries, which are very much at the heart of some of the applications that we're talking about in this area. So that's the membership of the Edge Protection Federation. And it also has put some of its knowledge into words as well. And I'm sure that if you stay for the other sessions, you'll hear mention about some of the advice and information available. The Edge Protection Code of Practice is a good example of that, because it goes a lot further than the design information I'm about to talk about, and gives you 36 pages of advice and guidance about best practice and the use of various types of equipment, various applications covering edge protection. So it's a very useful guide itself. Unfortunately, it's not a freebie, but it is very reasonably priced and available. So into the type of work. In terms of applications, these are sort of projects that we'll be talking about. Concrete frame, steel frame, industrial steel frame, which are different again, flat roofs, and the more recent area of climbing edge protection. Now, I thought it's worth mentioning just a little about the thing that underpins the applications covered by the edge protection industry, as it were. And it's this document, BSCN 13374, which may not be a name or number that tricks off the lips. Nevertheless, it's been quite a powerful document, because since it came in, it has spanned a whole industry in itself, and it's effectively ruled out the use of traditional methods like tube and fittings on hundreds and hundreds of projects throughout the UK, to the extent that tube and fittings is now the minority of edge protection in the UK, and these sort of systems are now very much the majority. This standard provides the performance proof, performance verification for all the products that are used on the applications I'm about to touch on. The design foundation is our guideline, and it advises us in terms of the technical support and the training support that we provide as an industry. And there are 3 classifications within that, classes A, B, and C, although most of them sit within Class A. And the reason for that is Class A covers mainly flat surfaces, as we know them, and with static loadings. Where you're talking about slight slopes, then it comes into Class B, and more substantial slopes are within Class C, which is a very different animal. So selecting equipment, as Alison mentioned earlier on, is very much the requirement to make sure that the right classification of equipment is being used. There's a training program as well run by the EPF, because given the hazardous nature of this sort of application, you're stopping people from falling off leading edges that may be from buildings that are 25 stories high. Yet some of the training for some of these applications is on the basis of 15 or 20 minute toolbox talk, which clearly we think is totally inadequate. So the one-day training program goes much further than that to try and give a great deal of advice based on specific systems, but also a lot of the generic information available to the Edge Protection Federation. So that, by way of general introduction, gives you an idea of the background of this industry and the fact that BSEN 13374 lies at the heart of it and gives us a marker point, a datum point, to be able to judge the performance of any of the solutions that are provided. So let me now just outline some of the types of equipment, types of applications that we're talking about. Some of these colours will be familiar to you if you drive up and down the country from time to time. You don't have to be sitting on a construction site or even in the centre of the city to see them. And they're one of the visual impact signs of the edge protection industry, because these are the emblems of particular companies as suppliers, of the contractors and their own house colours, and some of the indications that a safe method of edge protection is in place and reliable. So it literally has given us a bit of a new landscape within the construction industry. Those barrier frames, those colours, are used throughout most, but not all, of the applications that we encounter. So into some of those applications, and the most common one, I suppose, is that with concrete slabs. Now, this is where poured and cured concrete is available for fixing into. And the insertion of socket bases goes into usually drilled anchors using things like Hilti anchor fixings that give us the reassurance of a solid basis of support for a series of posts and panels. And that's the basis behind the sort of edge protection we're talking about with concrete slabs. But it isn't just drilled or drop-in anchors. It's also clamping components that can clamp to the edge of those slabs or clamp to upstand beams and similar features, but can also be clamping onto the aluminium formwork beams that are used prior to the concrete being poured. So these sort of clamping and drilled in anchorings are what would typify most concrete slab, concrete frame applications. And as I said, these are all Class A type systems because they're likely to be more or less flat surfaces being fixed into. And in a way, they are reasonably predictable. The ones that are less predictable, I'd suggest, are the emerging areas of steel frame. Steel frame construction has become very popular in the UK in the last few years, but it's presented its own fair share of problems because it seems to somehow give rein to highly variable and quite exciting designs of structures. But for the edge protection industry, as in the scaffolding industry, it can present quite a few problems because each building can be individual. And that's why there are quite a lot of individual fixings that have been designed for those. The most typical ones are where we're providing bolted in fixings using cantilever brackets that then allow room for the concrete oversail and some other edge profile details. Most importantly, this is probably the classic example of the work at height regulations in practice, because the way in which these are installed is to pre-drill the steelwork while it's still in the factory to the dimensions that are specified by the suppliers of those brackets, so that when the steelwork arrives on site, the brackets can be prefixed on the ground, the edge protection installed on the ground, and then craned into place. So it isn't necessarily to expose the workers to risk when they're installing it at height. That part of the process can be removed by this method of prefixing installation. And as I say, I think it's a great example of avoiding risks of working at height in this area. There are other variations to steel frame. The welded sockets are a simple example where they'll pre-weld on a socket to take a simple post. That has been quite a common method. It has begun to change more in favour of these systems, and I personally believe it will change far more significantly once the new BSCN 13374 comes in, because the signs of one of the requirements is that that type of fixing will probably no longer be acceptable. But there are other issues that we face where there are particular cladding details, extensions to the face of the building with the steelwork, with the design, where we're needing to find larger and larger cantilevers to the edge protection in order to push it further out from the face of the building to clear those sort of features. And there are also issues about the removal of some of these components afterwards, and that's why some of the single-sided fixings are also becoming a bit of a requirement, and where box sections are being detailed from time to time at these building edges, they're very difficult to get fixings into. So again, the single-sided fixings are being used in some places as a way of solving that particular problem. Then we have industrial steel frame, which is different again, and by these sort of applications I'm thinking about the Asda and Morrisons as well as industrial warehouses, and some of these weird names that you see on there, stub clamps and gable brackets, are signs of a more specialised side of the industry where they're having to adapt to quite individual applications very much at eaves level in order to try and provide some compliance with 13374 where the, should we say, optimum amount of steelwork in that structure makes it quite difficult. Where the columns are spaced 8 or 9 or 10 meters apart, and with only like cold rolled sections in between, it's quite difficult to achieve compliance with these systems. And again, I think a lot of the systems that are in use may be in question, and we may find some of those needing to change because I'm not sure that many of them actually comply with Class A. And then finally we come into Class C type systems. As I mentioned, these are for steeply sloping applications, and we don't have too many of those in the UK, but these sort of netting solutions are also used where all else fails, where there isn't a safe method of achieving a guardrail in quite complex designs of buildings. And sometimes the only solution is to install side netting and netting underslung in order to give the right sort of protection, even if it's potentially fall arrest, to the worker on those applications. Now, I haven't given examples of Class B, but visually they will be quite similar to some of the industrial steel frame applications. And then we have freestanding systems, which are different again, because these are the sort of edge protection you'll find on roofs for both temporary and permanent applications on flat roofs. You'll find these sort of systems in use, which again have replaced a lot of the traditional scaffolding applications. We still see scaffolding A-frames used, which don't comply with anything. So more and more these sort of freestanding systems, which are counterweighted, they don't involve drilling into the roof surface, are being used, but they also have a performance requirement under the 13374 standard. Now, in terms of more recent changes, one of the quite topical issues at the moment is about full height protection. If any of you have visited the Olympic Park while the Olympic Village was being constructed, you'd have seen a lot of this. And it's a demand by certain contractors to give the maximum amount of protection to avoid any objects being allowed to fall from that structure. And it's full floor to soffit protection. The issue for the industry is that there isn't, strictly speaking, a standard for that type of edge protection. And that's something that yet needs to be clarified. And climbing screens is another very topical subject at the moment. Again, if anybody wanders near London Bridge, you'll see the Shard going up, which has a number of climbing screens on it, the shape of which, the size and scale of them changes with every floor level. Climbing screens are a way of reducing risk by providing several levels of protection from one floor level below, so that the steel workers, the concrete workers, can actually have a level of protection that they wouldn't otherwise have with any other edge protection method. And I think you can draw the parallel here with the advanced guard railing steps being taken throughout the access industry, where the protection is there in advance of people accessing those floors. So climbing screens is very much new technology based on small hydraulic pumps, and I think is very much a sign of some of the systems to come in the future. We shouldn't forget the traditional adaptations where you can make uses for scaffold tube still, where we're putting these systems onto concrete staircases as well, where they're needing to find solutions to stopping people falling off the edge of vehicles, and that's another edge protection application that's relatively new. And the use of protection fans, to stop men and materials, ladies and men and materials falling out of buildings. And as you can see, that's a Class C type system too. And then we have the more unusual things like lift shaft protection. So finally, we have ground-based protection using the same systems and these industry issues. The fact that we're not involved as an industry early enough, particularly with these many varied steel designs, is a real problem. The fact that this is a real CDM issue, that they're optimizing the design of the steelwork, but not considering how we provide safe edge protection that complies with the standard. Full height protection and what standard that should comply with. The fact that even now there is inadequate training being given, I'd say, on the majority of edge protection applications in the UK. And more recently, the concern of contractors for tighter and tighter gaps to reduce the chance of any small object falling out of the building. And that can present real challenges for our industry. So, ladies and gentlemen, thank you for listening. That's the edge protection industry.